In this video, we are going to discuss the basics of electrical circuits. First, we are going to discuss what is voltage. According to the structure of an atom, there are two types of charges. One is positive charge and the another one is negative charge. A force of attraction exists between these charges, that is positive and negative charges. A certain amount of energy is required to overcome the force and to move the charge through a specific distance. All the opposite charges possesses certain amount of potential energy because of the separation between them. The difference in potential energy of the charge is called potential difference. In electrical terminology, the potential difference is termed as voltage and it is denoted by the letter V. It is expressed in terms of energy per unit charge. The potential difference or voltage is also represented by dW by dQ, where dW is the small change in energy and dQ is the small change in charge. The energy is expressed in joules and the charge is expressed in coulombs. And the voltage is represented as V and the unit is in volts. The potential difference between 2 points is said to be 1 volt when 1 joule of energy is used to pass 1 coulomb of charge from one point to other. Next, we will discuss about what is current. There are free electrons which are available in all the semiconductor and conducting materials. These free electrons move at random in all directions within the structure in the absence of external pressure or voltage. If certain amount of voltage is applied across the material, all the free electrons move in one direction depending on the polarity of the applied voltage, and it is shown in the figure. The movement of electrons from one end of the material to the other end constitute an electric current, and electric current is denoted by the letter I. The conventional direction of current flow is opposite to the flow of charges, that is the electrons. Current is defined as the rate of flow of electrons in a conductor or semiconductor material. It is measured by the number of electrons that flow or past a point in unit time. And the current is expressed in mathematically as I is equal to Q by T. Where I is the current and Q is the charge of an electron, and T is the time. The same current is also represented as dQ by dt, where dQ is the small change in charge and dt is the small change in time. Energy is the capacity for doing work. Energy is nothing but stored work. Energy may exist in many forms. Energy may be either in mechanical, chemical or electrical form. And power is the rate of change of energy and it is denoted by the letter P. If certain amount of energy is used over a certain length of time, then power is given by energy by time, that is represented by W by T. And the power is also denoted by dW by dt, where dW is the change in energy and dt is the change in time. Power is also given by the product of voltage into current, and the unit of power is watts, that is represented by the letter W. And the energy is measured in joules, that is represented by the letter J. 1 watt is the amount of power generated when 1 joule of energy is consumed in 1 second. Thus, the number of joules consumed in 1 second is always equal to the number of watts. amount of power is less than 1 watt or usually expressed in fraction of watts. In the field of electronics, power is expressed in either in milliwatts or in microwatts. In electrical field, power is represented in kilowatts or in megawatts. Radio and television stations use large amount of powers for transmitting the signals. Electrical circuit consists of three parts. One is energy source, and the energy source may be either generator or battery. And second part is load or sink. Example for this load is lamp or motor, and the third one is connecting wires. The connecting wires are used to connect energy source and load. The purpose of electric circuit is to transfer energy from source to the load, and this is carried out by the passage of electrons through the wires around the circuits. In the electrical circuit, the networks or elements are classified into four groups. One is active or passive element, second one is unilateral or bilateral element, third one is linear or non-linear element, and the fourth one is lumped or distributed element.